Hello, welcome everybody. This is your explanation with the rubric of the swimming pool problem. So this picture is a picture of a swimming pool. Radius is 12 feet, height is 4. Pool contains 1,000 cubic feet of water at 0. The interval is from 0 to 12. You got water coming in at P of t, and then there's water leaking at R of t. And they give you a table for P of t. They give you a function for R of t. Part A says use midpoint rectangles with equal subintervals to approximate the total water that was pumped into the pool. So into the pool is the table. So I drew a little picture here of all the water that's being pumped into the pool right there, a quick little picture. Many of you made a mistake when you do problems that are midpoint Riemann subs with 6 intervals. With 3 intervals, which the question says, and you guys read this as like 6 intervals because there's like 6 spots there. So a lot of people will do, instead of these 3 rectangles here, they'll do 6. So hopefully you fixed that since the last problem we did like this. So as you look at this, the picture is evident and here is the answer. So as you look at the answer, what you're doing here is you're doing, this is rectangle 1, 46 is what the height is from this part of the problem, 246. So now remember the width is 4 because it goes from 0 to 4. And then rectangle 2 is the 57 and 4, and 57 is that middle one right there. And then the last rectangle is 62 times 4. 62 is the middle and 4 is the width. So once you get all this, the midpoint sum is basically all of this work right here, and the answer is 600 cubic feet. So hopefully you set it up correctly, and then hopefully you did the math right and you got 600 feet. Pretty simple for that one. For part B, calculate the total amount of water leaked out of the pool during the time interval 0 to 12. So to figure out how much is leaked out of the pool, you just have to use that simple R of t function and take an integral from 0 to 12 of R of t. So that'll give you your total answer right here, which is 225.594. So the integral would be 1 point. Integral, meaning it has to have the 0 to 12, the correct limits, and has to use the correct function, which is either R of t, or R of t is this 25e function. And then the answer, of course, is 225.594 cubic feet. For part C, use results from A and B to approximate the volume of the water in the pool at t equals 12. Round your answer to the nearest cubic foot. So for this one, you need to have this amount of water that is coming in take away this amount of water is coming out. However, you have an initial condition of 1,000. So if you want to approximate the volume of the water of the pool, you have your initial 1,000, you add to it from the table, which was the answer to part A, and you take away the leaking part, which is the answer to part B. So that's the whole formula. Unfortunately, there's only 1 point here for the answer, and that is 1,434.406. So basically the answer, you just need that right there. Now it does say approximate it to the nearest cubic foot, so you should really only have 1,434 cubic feet. If you put the 0.406 on there like this, and you didn't round it to the nearest cubic foot, you weren't reading the problem and you don't get that point. Now for the last part, find the rate at which the volume of the water in the pool is increasing at time t equals 8. How fast is the water level rising in the pool at 8 indicate the units of measure in both answers. It's very rare that you get a problem like this in a free response because it's a related rates kind of question. So you want the rate of the volume, so the rate of the volume is the rate coming in minus the rate coming out. That's just the general case, but then you need this 8 part because it's asking for at 8. So to get the at 8 part, you define P of 8 and R of 8 and subtract them. P of 8 is 60, right from the table, and R of 8 is plugging in 8 into that function, and your V of 8 answer for the points is one of these two. That's for the first point. Now, the second part is, well, how fast is the water level rising? So you need to start with your function here, which they kind of hinted to you right here, that that's your function. And this is the related rates portion. Because the radius is not changing, you could plug in 12 immediately in for the r, and that gives you the pi times 12 squared, so 144 pi h. But when you want the how fast is the water level of the pool rising, you want to figure out the rate of that. So you need the dv/dt portion. So this is the 144 pi right there, and then you need a related rates answer. So you need to throw in dh/dt. So an equation relating this means you correctly did the related rates portion right. So it's this step right there. Following that, you then need to come up with your dh/dt at d equals 8, and that is done by dividing this by 144 pi, both sides. So you could take dv/dt divided by 144 pi, or they multiplied it by the reciprocal. So either way. So that answer right here is how you get this third point. And then the units of cubic feet per hour and feet per hour, and it's both and. So you're going to need the feet per hour right there because that's the height of the water level. And you need your units for A, cubic feet per hour, to get your 9th point. I hope you got it. Hope you did well. Don't forget to put at the top how many you received out of 9 points. Thanks for listening.